So in this example, we have two charges. Q1 at the left has a charge of 3.2 times 10 to the negative 9 coulombs. Q2 at the right, negative 6.4 times 10 to the negative 9 coulombs. They are 42 centimeters apart. And we want the net electric field strength at a point P 15 centimeters from the positive charge. That would be Q1. So we know in total the distance is 42 centimeters. We know this distance is 15 centimeters. Means this distance has to be 27. And that will be important as we go to calculate. We do need to calculate the electric field of each charge at point P, and then we'll find the net charge after that. So dealing with Q1. We know the distance is 15 centimeters, but to calculate that, we need 0.15 meters. The charge is positive 3.2 times 10 to the negative 9 coulombs. We will need K as well, but we can look that up. Going to the formula, epsilon equals KQ over R squared. Which would be 8.99 times 10 to the 9th times 3.2 times 10 to the negative 9th over 0.15 squared. Working that out to 2 sig figs, we get 1300. Field strength is measured in newtons per coulomb. And because this charge is positive, we will assign a direction that is to the right. Same process for the second charged object. This time the distance is 27 centimeters from point P, which is 0.27 meters. Charge Q2 is negative 6.4 times 10 to the negative 9 coulombs. Calculating the field strength, KQ over R squared, 8.99 times 10 to the 9th times negative 6.4 times 10 to the negative 9th, which is over 0.27 squared. Working that out, again 2 sig figs, we get negative 790 newtons per coulomb. Or assigning a direction, that would be positive 790 newtons per coulomb to the left. Now that we have the strength of the field from each charge, we can calculate the net field strength, same way as we would calculate net force. The field strength from charge 1 plus the field strength from charge 2. Which would be 1300 newtons per coulomb to the right plus 790 newtons per coulomb to the left. Not having the same directions, we do need to change that. I'll make these both to the right, which would mean we would have minus 790 newtons per coulomb to the right if we flip that one around. Which would give us a net field strength of 510 newtons per coulomb to the right.